Unity Certified User, Programmer 2026. Welcome to our video for the Unity Certified User Programmer Practice Exams of 2026. I will help you learn the core concepts so you can achieve your coding dreams. You can get my complete practice test link in the description or at the first comment. This link gives you a discount coupon for the complete practice questions with full explanations. These explanations will definitely help you get your certification easily on your very first try. Please leave your helpful suggestions in the comment section to improve my future video content. And please, do not forget to subscribe to my channel for more amazing learning videos. Section 1. Let us start with the basic Unity interface, because you need to know your workspace. The hierarchy window shows all the items which currently exist inside your active game scene. The scene view gives you a visual way to move and rotate your game objects. Next, we have the inspector window, which displays details about your currently selected game object. You can change values like position or color right here in this very useful panel. The project window is where you store all your files, like scripts and sound clips. To make things do something, we write code using a programming language called C#. We attach these code scripts to our game objects, just like adding a new part. Unity uses a component system, meaning each object gets its behavior from these attached scripts. Inside a script, we use variables to store data, like a player's health or score. A variable needs a specific type, such as an integer for whole numbers without decimals. We use a float for numbers with decimals, which is great for measuring moving speeds. A string variable holds text, which you can use to show names or dialog messages. A Boolean variable only holds two simple values, which are either true or completely false. You must always declare the type of variable before you can use it in code. Functions are blocks of code that are a specific job when you call their name. The start function runs only one time, right at the beginning of the object's life. The update function runs many times a second, usually once for every single visual frame. We use the update function for things that change, like checking if a key is pressed. If you want to test your code, you can print messages to the Unity console. You do this by typing debug.log, followed by your message in round brackets. This logging helps you find mistakes, so you know exactly what your code is doing. If your player falls through the floor, a log message can tell you the reason. Finding and fixing these mistakes is called debugging, which is a normal part of programming. Game objects are the basic building blocks for everything you see in your Unity game. An empty game object does absolutely nothing until you add some components to its structure. Every single game object always has a transform component, which controls its position and size. The transform component also controls rotation, telling the object which direction it should face now. You can drag one object onto another in the hierarchy to make it a child. The child object will move and rotate whenever the parent object moves around the scene. This parent and child relationship is very helpful for building complex things like a car. You can group the wheels under the main car body to keep everything organized together. When the car body moves forward, all the attached wheels will move forward with it. Let us talk about saving your hard work so you do not lose your progress. A Unity project is made of many scenes, which are like individual levels in a game. You must save your scene frequently by pressing Ctrl and the letter S on Windows. If you make a change in play mode, the changes will disappear when you stop. This is a common mistake for beginners, so always remember to stop playing before editing. Play mode is only for testing your game, to see how everything feels and works. You can also save your game objects as prefabs, which act like reusable master templates. When you update a prefab file, every copy in your game will update as well. This saves you a lot of time when you have 50 identical enemies to manage. To create a new prefab, simply drag an object from the hierarchy into the project. The object will turn blue in the list, showing that it is now connected properly. You can drag this new prefab back into the scene to make another exact copy. We need to understand public and private variables because they change how your scripts work. A public variable shows up in the inspector, allowing you to change it without coding. A private variable stays hidden in the code, so other scripts cannot mess it up. If you want a private variable in the inspector, you use serialize field above it. This is a great trick for keeping code safe, while still making it easily adjustable. You should always try to keep variables private, unless another script really needs that data. Another helpful concept is the awake function, which runs even before the start function runs. You use awake to set up references, so the script knows where to find things. Start is better for doing things after all the initial setup is completely finished. Understanding these basic Unity concepts is the first step toward getting your programmer certification easily. We will practice these ideas together, so you feel ready when the real exam starts. Practice makes you much better at coding, so do not worry if you make mistakes. Just keep writing small bits of code, and you will learn how the system works. Train, test, we need to fix, repeat, until your game runs smoothly without any errors. Now we will look at some questions to test what we have just talked about. You should also know about the console window, because it shows red text for errors. When your code has a spelling mistake, the console will tell you exactly which line. You can double-click the error message to open your code editor right to it. The main camera is another special object, which shows what the player will actually see. Without a camera in your active scene, your game screen will just be completely black. You can move the camera around the world, just like any other normal game object. Directional lights act like the bright sun, giving basic light to your entire 3D world. You can change the light color and strength to make your game look totally different. Now let us move to the practice questions, so you can test your new knowledge. Question 1. What happens when you drag a game object into the project folder window? It creates a reusable prefab asset, which you can place anywhere in your game scene. This allows you to easily make multiple copies, without setting up the same object again. Question 2. Which window do you use to change the color of a specific game object? You use the inspector window, which shows all the details for the currently selected item. The inspector lets you modify the properties for every single component attached to your object. Question 3. What specific data type should you use to store a player's exact text name? You should use a string variable, because it is designed to hold text-based characters. Strings are perfect for storing words, sentences, or any dialogue you want to display on screen. Question 4. How often does the update function run when you play your Unity game scene? It runs one time every single frame, making it perfect for moving your player character. Since it runs so very fast, you use it to check for player input constantly. Question 5. Why would you mark a variable as private inside your custom C# script? To keep the data completely hidden, so other scripts cannot accidentally change the current value. This protects your code from unexpected bugs, making your entire game much safer to run. Question 6. What command do you type to print a simple text message into the console? You type debug.log, followed by your custom text inside some round bracket marks. This is the best way to test things, because you see what the code actually does. Question 7. What happens if you forget to attach your new script to a game object? The code will never actually run, because Unity does not know it is needed yet. A script must live on an object for its instructions to be read and executed. Question 8. Which component is automatically added to every single new game object you create? The transform component is always added, to track exactly where the object is located. You cannot delete the transform component, because every item must have a physical space position. Question 9. What happens to changes you make while the Unity editor is in play mode? All of your recent changes are lost the moment you press the Stop Play button. Play mode is just a temporary test, so you must edit your game beforehand. Question 10. How do you make a child object move with its larger parent game object? You simply drag the child onto the parent, right inside the main hierarchy list window. This groups the objects firmly together, so they share the exact same movement and rotation. Question 11. What simple data type is best used for storing a true or false condition? You should use a Boolean variable, because it only ever holds true or false states. This is very useful for checking things, like whether a player is jumping or not. Question 12. Which function runs before the start function, to set up your basic object references? The awake function runs first, making it the perfect place to link up your components. Using awake ensures everything is fully ready, before the start function begins doing its work. Question 13. What window shows you all the files and folders stored inside your current project? The project window displays every file, like your audio clips and your C# scripts. This window acts like a file manager, keeping all your important game assets neatly organized. Question 14. What must you add above a private variable, to see it in the inspector? You must write serialize field above it, enclosed in a pair of square bracket marks. This reveals the hidden variable to you, without exposing it to other external code scripts. Question 15. What specific window shows a list of every item currently existing in your scene? The hierarchy window provides a complete text list of everything sitting in the active level. If you lose an object in space, you can easily select it from this helpful list. Question 16. What type of number should you use to store a value with decimal points? You must use a float variable, which allows for very precise decimal point math calculations. Floats are the standard choice in Unity for handling speeds, distances, and exact time measurements. Question 17. How can you find the exact line of code that is causing a problem? You look at the red text error message, which is displayed in the console window. Double-clicking this helpful error message will open your code directly to the broken line. Question 18. What basic object gives light to your 3D world so you can see things? A directional light acts like the sun, brightening up your entire game level for you. Without a light source in the scene, all your detailed 3D models will look completely black. You can find the full course link right down in the description of this video. Please check it out today, so you can practice more questions and pass your exam. Section 2, we will focus on how objects move and interact using physics. Unity has a very powerful system that handles gravity and collisions for you automatically. To make an object fall down, you must add a Rigidbody component to it. This component tells Unity that this object should follow the laws of physics. When you have a Rigidbody, you can change the mass to make things heavy. A heavy box will behave differently than a light ball when they hit each other. You can also turn off gravity for specific items if you want them to float. This is very useful for space games, where you do not want things falling. Colliders are the invisible shapes that define the physical boundaries of your game objects. Without a collider, objects will just pass through each other like ghosts in the night. You can use a box collider for a crate, or a sphere collider for a ball. Using the right shape helps the game run faster, because complex shapes take more work. Sometimes you want a collider to detect things, without actually stopping them from moving. For this, we use the is-trigger setting, which turns the collider into a zone. When something enters this zone, it sends a message to your script for you. This is how you collect a gold coin, or trigger a hidden trapdoor. To use these triggers, we write a special function called onTriggerEnter. This function needs to know which other object just stepped into the detection zone area. You can check the name or the tag to see if it was the player. Using tags is a great way to group objects, like labeling all enemies as enemy. If you want objects to bounce or slide, you need a physics material asset. You can set the bounciness to a high number to make a super bouncy ball. Friction controls how much things slide, which is perfect for making an ice patch. You drag this material into the collider component to apply the new physical properties. Moving objects through code is very common, and there are two main ways to do it. You can change the position directly by modifying the transform component every single frame. Or you can add a force to the Rigidbody, which feels much more natural and smooth. Adding a force is like giving a physical push to a ball on the ground. When using physics in code, we use a special function called fixed update instead. Normal update runs as fast as it can, but fixed update runs at steady times. This makes your physics calculations stay stable, no matter how fast the computer is running. Always put your Rigidbody movements inside fixed update to avoid any strange jumping or glitching. Let us talk about input, because you need a way to control your main character. Unity has an input manager, where you can define keys like WASD or the arrows. You use input.getAxis to get a number between -1 and 1. This number tells you if the player is pushing left, right, up, or down. You can also check for specific key presses, like the spacebar for a jump. Input.getKeyDown only happens once, the very moment the key is pressed. Input.getKey stays true as long as the player keeps holding the key down. This is perfect for continuous actions, like firing a machine gun or running fast. Vectors are used to represent directions and positions in a three-dimensional game world. A vector 3 has three numbers, which represent the x, y, and z axes in space. X is usually for left and right, y is for up and down, and z is for forward. Understanding how these axes work together is vital for moving your characters correctly. Sometimes you need to find an object that is already sitting in your game scene. You can use GameObject.find, which searches for an object by its name. However, searching by name is very slow, so do not do it inside the update function. It is much better to find the object once, inside the awake or start functions. A better way is to use GameObject.find with tag, which is faster. This looks for any object that has the specific tag you are looking for right now. Once you find the object, you can get its components using getComponent. This allows your script to talk to other scripts, or change the object's color. Let us look at how we can destroy objects when they are no longer needed. You use the destroy function to remove an object completely from the game world. You can also add a timer, so the object disappears after a few seconds. This is great for smoke effects, or bullets that missed their target in battle. To create new objects while the game is running, we use the instantiate function. This takes a prefab and makes a real copy at a specific position and rotation. You use this to spawn enemies, or fire projectiles from a player's powerful weapon. It is one of the most important functions for any Unity game developer. Prefabs are your best friend here, because you can spawn them very easily with code. You keep a reference to the prefab in your script, using a public variable. Then you just tell Unity to instantiate that prefab whenever the player clicks the mouse. This makes your game feel dynamic and alive, with things happening all the time. Vectors also help you calculate the distance between two different points in your game world. Vector 3.distance will give you a single number, showing how far apart they are. You can use this to see if the player is close enough to open a door. It is a simple but very useful tool for creating many game mechanics. Remember that physics can be heavy for the computer to calculate all the time. Do not add a Rigidbody to every single blade of grass in your big field. Only use physics components on items that really need to move or hit other things. Keeping your scene clean and efficient is a sign of a very good programmer. Always test your physics settings to make sure they feel right for your game. Sometimes a box might feel too light, or a character might bounce too much. Adjust the numbers in the inspector until the movement feels exactly like you want it. Train, test, we need to fix, repeat, until your physics world is perfect. Now let us test what you have learned, with some more practice questions for you. Pay close attention to the details, because the exam likes to ask about specific components. These questions will help you remember how Unity handles the physical world and input. Question 1. Which specific component must you add to an object to make it fall with gravity? You must add a Rigidbody component, which allows the Unity physics engine to move it. The Rigidbody handles all physical forces, including gravity, mass, and any pushes from other items. Question 2. What happens if you check the is trigger box on a box collider component? The object becomes a detection zone that other objects can pass through without hitting it. It no longer acts like a solid wall, but it can still detect when things enter. Question 3. Which function is the best place to put your physics-based movement code scripts? You should always use the fixed update function for any code that moves a rigid body. Fixed update runs at a steady rate, which keeps your physics looking smooth and very stable. Question 4. How can you make a player's character bounce when it hits a hard stone wall? You must create and apply a physics material with a high bounciness value to the collider. Physics materials control how surfaces interact, including how much they slide or how high they bounce. Question 5. What function do you use to create a new copy of a prefab during gameplay? You use the instantiate function to create a live instance of any prefab asset you choose. This is how you spawn enemies, bullets, or any other items while the game is currently running. Question 6. What is the difference between input.getKey and input.getKeyDown? GetKeyDown only happens once per press, while getKey stays true while held. Use getKeyDown for single actions like jumping, and getKey for continuous actions like running. Question 7. How do you find a specific component, like a light, on another game object? You use the getComponent function to look for and access that specific type of component. This allows your scripts to talk to each other and change values on different parts of objects. Question 8. Which vector 3-axis usually represents the up direction in a standard 3D Unity scene? The y-axis represents the up and down direction in the Unity 3-dimensional coordinate system. Increasing the y value will move an object higher, while decreasing it moves the object much lower. Question 9. What function is called automatically when an object enters a trigger collider zone? The onTriggerEnter function is called when a rigid body first touches the trigger zone boundaries. You can write code inside this function to give the player points or start a movie. Question 10. How do you remove an object from the game world when it is no longer needed? You use the destroy function to delete the game object and free up the computer memory. This is important for keeping your game fast by getting rid of old bullets or dead enemies. Question 11. What does the mass property on a rigid body component actually change about the object? It changes how much force is needed to move it and how it hits other objects. A higher mass makes the object harder to push, just like a heavy rock in the real world. Question 12. Which function should you use to check for a single mouse click from the player? You should use input.getMouseButtonDown to detect the exact moment of the click. This ensures the action only happens once per click, instead of repeating every single frame of game. Question 13. How do you identify a group of objects, like all the coins, in your game level? You assign a specific tag to the objects, and then search for that tag in code. Tags are labels that let you group items, making it very easy to find all coins at once. Question 14. What happens if an object has a rigid body, but no collider component attached to it? The object will fall through the floor, because it has weight but no physical shape boundaries. You need both components together, if you want an object to fall and then land on something. Question 15. What is the result of using vector 3.distance between two game object positions? It returns a float number, which represents the direct physical distance between those two specific points. This is perfect for checking if a player is close enough to talk to a non-player character. Question 16. Why is it bad to use GameObject.find inside the update function of a script? It is a very slow operation, which can make your game lag if it runs every frame. You should find your objects once at the start, and then save them in a variable for later. Question 17. How can you prevent a rigid body from falling, even if gravity is turned on globally? You can check the "is kinematic" box, which stops physics forces from moving the game object. A kinematic object can still move through code, but it will not react to gravity or collisions. Question 18. What is a vector 3 variable actually made of, in the C# programming language? It is made of 3 float numbers, which represent the x, y, and z positions in space. These 3 numbers define exactly where an object sits, or which direction it is currently pointing towards. Section 3. In this section, we will look at how to control game flow and make decisions in your code. To make a game interesting, your scripts need to check if certain things are happening right now. We use if statements to tell the computer to do something only when a specific condition is true. For example, if the player's health is 0, then we show the game over screen. You can also use an else block to give an alternative choice when the first condition is false. This is like a fork in the road, where the code can go left or right. If it is raining in your game, show an umbrella, otherwise, show a pair of sunglasses. This logic allows your game to react to the player, making the world feel much more alive. Sometimes you need to check multiple conditions at once, using and, or operators in your script. The and operator, written as 2 ampersands, means both things must be true for the code to run. The or operator, written as 2 vertical lines, means the code runs if at least one thing is true. This helps you create complex rules, like checking if a player has a key and is at a door. When you have many different options for one variable, a switch statement is much cleaner than many if statements. It looks at a single value and jumps directly to the case that matches that specific value. This is perfect for player states, like switching between idling, running, jumping, or attacking your many enemies. Loops are used when you want to repeat a piece of code many times without writing it over and over. A for loop is great when you know exactly how many times you want the code to repeat itself. You can use a loop to spawn 10 enemies in a row, or to check every item in a list. This saves you a lot of typing time, and keeps your script files very small and clean. A while loop keeps running as long as a condition is true, so you must be very careful with it. If the condition never becomes false, your game will freeze because the computer is stuck in an infinite loop. Always make sure there is a way out, like a counter that goes up until it reaches a limit. Loops are powerful tools, but they require a steady hand to use them correctly in your game. Arrays and lists are used to store many items together under one single variable name in your C# script. An array has a fixed size, which means you cannot change how many items it holds after you create it. A list is more flexible, because you can add or remove items while the game is actually running. Lists are usually better for things like an inventory, where the number of items changes often. To get an item out of a list, you use an index number, which always starts at 0, not 1. This is a very common mistake for new programmers, so try to remember that the first item is 0. If you have 5 items, the last index number will be 4, because we started counting from the 0. Accessing items by their index is very fast, letting you grab the right data in a split second. Let us talk about classes, which are like the blueprints for your game objects and all their custom behaviors. A class can contain variables to store data, and functions to perform actions using that specific data. When you create a script in Unity, you are actually creating a new class that inherits from mono behavior. Inheritance means your script automatically gets all the cool powers that Unity's built-in system already has. Methods are just functions that belong to a class, and they help organize your code into small, manageable pieces. It is a good habit to keep your methods focused on doing just one single job very well. One method can handle player movement, while another method handles the health system and taking damage from enemies. This makes it much easier to find and fix bugs when something goes wrong in your game. Variables have a scope, which defines where in the code you are allowed to see and use them. A variable created inside a function is local, meaning it disappears once that specific function is finished running. A variable created at the top of the class is global to that script, and all functions can see it. Using the right scope keeps your code organized and prevents different parts of your script from interfering. Namespaces are used to group related classes together, like a folder for your code files to keep things neat. You might see using Unity Engine at the top of your script, which tells the computer to use Unity's tools. Without this line, the computer would not understand what a game object or a transform is. Namespaces prevent name conflicts, in case two different people named their class the same thing by accident. Comments are notes you write for yourself or other humans, which the computer ignores completely when running the code. You start a single-line comment with 2 forward slashes to explain what a tricky piece of code does. For longer explanations, you can use a block comment, which starts with a slash and a little star symbol. Writing good comments is a sign of a pro, and it helps you remember your logic later. As you build more complex games, you will need to learn how to organize your files and your logic. A well-organized project is easy to expand, while a messy project will eventually become impossible to manage. Use folders for your scripts, your sounds, and your textures to keep your project window looking very professional. Train, test, we need to fix, repeat, until your code is as clean as a whistle. Now we are going to look at some practice questions to see if you understand these coding logic concepts. These questions are very similar to what you might see on the real Unity Certified User exam. Take your time and think about how the code moves from one line to the next as it runs. Question 1. Which keyword do you use to check a condition and run code only if that condition is true? You use the if keyword to create a conditional statement that controls the flow of your script. It allows the game to make decisions, like checking if the player has enough points to win. Question 2. What is the starting index number for the very first item stored inside a C# list? The first item always sits at index 0, because computers start counting from 0 instead of 1. This is a fundamental rule in programming, and forgetting it often leads to errors in your code. Question 3. What happens to a local variable once the function it was created in finishes running? The local variable is destroyed, and the computer memory it was using is freed up for other things. Local variables only exist for a short time, to help a function finish its one specific task. Question 4. Which loop is best to use when you know exactly how many times you want to repeat? The for loop is the best choice, because it has a built-in counter to track each repeat. You set a start, an end, and a step, making it very precise for spawning a row of items. Question 5. What is the main difference between a standard C# array and a C# list? An array has a fixed size, while a list can grow or shrink while the game is running. Use lists when you don't know the final count, and use arrays when the size never changes. Question 6. What does the else keyword do when added after an initial if statement in your code? It provides a block of code to run only if the first if condition was found to be false. This creates a simple two-way choice, ensuring that at least one piece of code always runs. Question 7. What symbol is used in C# code to represent the logical AND operator between two conditions? You use two ampersand symbols together to check if both the first and second conditions are true. If either side is false, the whole thing becomes false, and the attached code will not run. Question 8. Which statement is better than many if statements for checking one variable against many constant values? The switch statement is much cleaner, because it jumps straight to the case that matches your variable. It is very easy to read, especially when handling things like different player states or game levels. Question 9. What is a namespace used for in the C# programming language used by Unity developers? It is used to group related classes together and to prevent naming conflicts between different pieces of code. It works like a container, keeping your code organized and helping the computer find the right tools. Question 10. How do you write a single-line comment that the computer will ignore when it runs your script? You start the line with 2 forward slashes, which tells the computer to skip everything on that line. Comments are for humans to read, helping you and your team understand the logic of the code. Question 11. What does it mean when a class inherits from another class, like mono-behavior in a Unity script? It means the new class gets all the variables and functions that were defined in the parent class. This is why your scripts can use things like start and update without you writing them yourself. Question 12. What is the main danger of using a while loop if you are not very careful with your code? You might create an infinite loop, which will cause your game to freeze and stop responding to players. If the loop condition never becomes false, the computer keeps running the same code forever and ever. Question 13. Which mathematical operator do you use to see if two values are exactly equal to each other? You must use two equals signs together, which is the comparison operator for checking equality in C#. A single equals sign is for giving a value, but two equals signs are for asking a question. Question 14. What keyword do you use to stop a loop early, or to exit out of a switch case? You use the break keyword, to tell the computer to jump out of the current code block. This is essential in switch statements, to prevent the code from running into the next case by mistake. Question 15. What is a method in C#, and why is it useful to use them in your scripts? A method is a block of code that does a specific task, making your script easier to read. By breaking your code into methods, you can reuse the same logic multiple times without rewriting it. Question 16. What do we call the three numbers that represent an object's position in a 3D Unity scene? We call this a vector 3, which contains the x, y, and z coordinates for any point in space. Every object needs a vector 3 to know where to stand, or which way it should be moving. Question 17. How can you combine two strings of text together to make one longer sentence in your game? You can use the plus symbol to add one string to the end of another string very easily. This is called concatenation, and it is great for showing messages like hello plus a player's name. Question 18. What is the scope of a variable that is declared at the very top of a C# class? The scope is global to the entire class, meaning every function inside that script can see it. This allows you to share data, like a player's score, between many different functions in your script. You can get my complete practice test link in the description or at the first comment of this video. These questions come with full explanations, which will help you get your certification on the first try. Don't forget to subscribe. Section 4. In this part, we will look at how to build the user interface, which players use to interact with your game. The user interface, or UI, includes things like health bars, buttons, and the main menu screens. All UI elements in Unity must sit inside a special object called a canvas. The canvas acts like a flat sheet of glass that stays in front of the game camera at all times. When you create a canvas, Unity also adds an event system object to your hierarchy automatically. The event system is very important, because it handles all the mouse clicks and screen touches from the player. If you delete the event system by mistake, your buttons will stop working, and you cannot click anything. Always keep this object in your scene, if you want your menu to respond to the player. UI elements use a special component called a rect transform, instead of a regular transform component. A rect transform allows you to anchor items to the corners or the center of the screen. This is helpful because screens come in many sizes, like tall phones or wide computer monitors. Anchoring ensures your health bar stays in the top corner, no matter how the screen size changes. Buttons are one of the most common UI elements, used to start the game or open the settings. A button component has an on-click section, where you can link a function from your script. When the player clicks that button, Unity will run the code you linked, like loading a new level. This makes it very easy to create interactive menus, without writing a lot of complex input code. To show text on the screen, like a score or a timer, we use the text component. You can change the font, the size, and the color right inside the inspector window for that object. In code, you must include using UnityEngine.ui at the top of your script to talk to it. Then you can change the text string whenever the player gains points or loses some health. Images are used for backgrounds, health bar fills, or icons for the items in your inventory. To show an image, you must first change your texture file to a sprite in the import settings. Once it is a sprite, you can drag it into the source image slot on the UI image component. This makes your UI look beautiful and much more professional than just using simple plain text. Sliders are perfect for making health bars or volume controls in your game's options menu. A slider has a value that goes from 0 to 1, which you can change with code. You can also make the slider whole numbers only if you are making a volume selector for the player. Sliders give a great visual way for players to see their progress or their current settings. The UI system also includes toggle switches, which are great for turning things on or off quickly. You can use a toggle for mute sound option or to enable a special hard mode setting. Toggles have a value changed event, similar to the button click event we talked about earlier. This lets your code react instantly whenever the player flips the switch in the menu. Input fields allow the player to type in their name or enter a secret cheat code during gameplay. You can limit the input to only numbers or only letters, depending on what you need from them. When the player finishes typing, your script can grab the text and save it for later use. This is essential for high score boards, where players want to see the names at the very top. Panels are used to group different UI elements together, like a window for a shop or an inventory. You can turn a panel on or off to show or hide a whole group of items at once. This keeps your screen from being too cluttered, so the player only sees what they need right now. Organizing your UI with panels makes your game feel much more polished and easy to navigate. Let us talk about raycasting, which is how Unity knows which UI element you are clicking on. When you click, Unity fires an invisible laser beam from your mouse position into the UI canvas screen. If the laser hits a button, that button will trigger its click event and run your code. This system is very fast and handles many different UI elements sitting on top of each other. To make your UI look good on all screens, you should use the Canvas Scaler component. This component can scale your UI elements based on the width or the height of the current screen. This prevents your buttons from looking tiny on a high-resolution screen or too big on a phone. It is a vital step for making your game playable for everyone around the world. Sometimes you want to show a 3D object inside your 2D UI, like a spinning gold coin icon. You can use a special render texture to capture a camera view and show it on a UI raw image. This is a more advanced trick, but it makes your interface look very high quality and dynamic. It is great for character select screens, where you want to see the hero in 3D. Animations can also be used on UI elements to make them fade in or bounce when clicked. You can use the animator component on a button to change its scale when the mouse hovers over it. This gives the player feedback, letting them know that the button is interactive and ready to be used. Little details like this make a huge difference in how your game feels to the player. Remember that UI elements are drawn in order, from the top of the hierarchy list to the bottom. Items at the bottom of the list will be drawn on top of items at the top. If your button is hidden behind a panel, move the button lower in the hierarchy to see it. Keeping your UI organized will save you a lot of time when you have many elements. Train, test, we need to fix, repeat, until your user interface is smooth and very easy to use. A good UI should be clear, so the player never has to guess what a button does. Use icons and short text to guide the player through your game's world and its many menus. Now we will test your UI knowledge with some practice questions for the programmer certification. Question: 1. What object must be present in your scene for your UI buttons to respond to mouse clicks? The event system object must be in the scene to handle all the input events for the canvas. Without an event system, Unity cannot detect when you are clicking or touching any of your UI buttons. Question 2. Which special component do UI elements use to control their size and their screen position? They use the Rect Transform component, which allows for anchoring and stretching across different screen resolutions. This is different from a regular transform, because it handles 2D layout and screen alignment much better. Question 3. Where must every single UI element be placed in order to be visible to the player? All UI elements must be children of a canvas object, which acts as the main display container. The canvas defines how the UI is rendered, either on the screen or inside the 3D game world. Question 4. What must you include at the top of your script to change a UI text component in code? You must write using UnityEngine.ui to access all the built-in user interface classes and their functions. This namespace contains the code for buttons, images, sliders, and all the other standard UI components. Question 5. What happens when a player clicks a button that has a function linked to its onClick event? Unity will automatically run the code inside that linked function the moment the mouse button is released. This is the primary way to make menus interactive, allowing players to navigate through your game levels. Question 6. How do you make a UI element stay in the bottom right corner, even if the screen size changes? You must set the anchor points of the Rect Transform to the bottom right corner of the parent canvas. Anchors tell the UI element which part of the screen it should follow, keeping the layout very consistent. Question 7. Which UI component is best for creating a visual health bar that fills up or empties out? The slider component is the best choice, because you can easily move the handle or fill area. By changing the slider's value between 0 and 1, you can visually represent a player's remaining health. Question 8. What type of file must a texture be before you can use it in a UI image component? The texture must be set to the Sprite 2D and UI texture type in the import settings. UI image components only accept sprites, so you must convert your regular images before using them in UI. Question 9. What component on the canvas handles scaling UI elements for different screen resolutions and sizes? The Canvas Scaler component manages the size of all UI elements based on the current screen dimensions. This ensures your menu looks the same size on a mobile phone as it does on a computer. Question 10. How can you group multiple UI elements together so you can hide them all at once? You can place all the elements inside a single panel object and then disable that one panel. When you hide a parent object, all of its children are hidden automatically, which is very efficient for menus. Question 11. What is the purpose of an input field component in a Unity user interface menu? It allows the player to type in text using their keyboard, which the script can then read and use. This is commonly used for player names, password fields, or searching through a large inventory list in-game. Question 12. In what order does Unity draw UI elements that are listed in the hierarchy window? Unity draws them from top to bottom, meaning the items at the bottom appear on top of others. If you want a pop-up to appear over everything, it must be the last item in your hierarchy list. Question 13. Which UI component is used to display a static title or a dynamic score on the screen? The text component is used to show any string of characters to the player during the game. You can update the text through code to show the current time, score, or instructions for the player. Question 14. What is a toggle component used for in a standard game settings menu screen? It is used for options that are either on or off, like a checkbox for enabling sound effects. Toggles are perfect for Boolean settings, where the player only has two distinct choices to make at once. Question 15. How does Unity know which UI button you are currently hovering over with your mouse cursor? It uses the graphics raycaster component on the canvas to fire invisible rays at the UI elements. If the ray hits an element that has raycast target enabled, Unity knows the mouse is touching it. Question 16. What setting on an image component allows it to act like a filling progress bar? You must change the image type to filled, which then gives you a fill amount slider to move. This is a very common way to create circular timers or horizontal loading bars in many video games. Question 17. Can you have multiple canvases in a single Unity scene at the same time? Yes, you can have many canvases, and you can even place them on 3D objects in the world. World space canvases are great for showing health bars, floating directly above the heads of your enemies. Question 18. Why would you use a raw image component instead of a regular UI image component? Raw images are used to display textures or render textures that are not converted into the sprite format. Use raw image for things like minimaps or live camera feeds that show another part of the world. Section 5. In this section, we will look at how to manage your game scenes and how to build your final project. A game is usually made of many different scenes, like a main menu, a loading screen, and the actual levels. To move between these, you must use the Scene Manager class in your C# script. Before you can load a scene, you must add it to the build settings list in the Unity editor. To use the Scene Manager, you must include using Unity Engine.Scene Management at the very top of your script file. You can then use Scene Manager.LoadScene to jump to a new level using its name or its index. Loading by index is often better, because it is faster and stays the same even if you rename the scene. This is how you transition a player from a successful mission back to the main map screen. When you load a new scene, all the objects in your current scene are destroyed to save memory. Sometimes you want an object to stay alive, like a music player or a game manager that tracks scores. You can use the "Don't Destroy on Load" function to keep a specific object across all your different scenes. This is a very powerful tool for persistent data, ensuring your background music never stops playing during a transition. Managing your project assets is just as important as writing the code for your game mechanics. You should use a clear folder structure to keep your textures, models, and sounds easy to find at all times. Using a consistent naming convention, like starting all script names with player or enemy, helps you work much faster. A clean project is a happy project, and it prevents you from making silly mistakes during development. Unity uses packages to add extra features, like better text tools or special 2D game systems. You can manage these through the Package Manager, which lets you download and update official Unity tools easily. This keeps your project size small, because you only include the specific features that your game actually needs. Always check for updates, to ensure you have the latest bug fixes and the newest performance improvements. When you are ready to share your game, you need to build it for a specific platform. Unity can build games for Windows, Mac, Android, iPhones, and even web browsers using a format called WebGL. Each platform has different settings, so you might need to adjust your graphics or your controls accordingly. Building your game is the final step, where Unity turns all your assets into a playable file. Before building, you should look at the player settings to set your game's icon and the company name. You can also choose the resolution and decide if the game should run in a window or full screen. These settings are important for your brand, and they make your game look professional to the players who download it. Always test your build on the target device to make sure it runs as smoothly as it did in the editor. Performance is a big deal, especially if you are building a game for mobile phones or older computers. You can use the Profiler window to see exactly which parts of your game are running slowly or using too much memory. It shows you graphs for the CPU, the GPU, and the memory usage in real time while you play. This helps you find the bottlenecks, so you can optimize your code and make your game run faster. A common way to improve performance is occlusion culling, which tells Unity not to draw objects the camera cannot see. If a big wall is blocking 100 trees, Unity will skip drawing those trees to save processing power. This is different from frustum culling, which only hides things that are physically behind the camera's view area. Using both methods together will keep your frame rate high and your gameplay feeling very responsive. Lighting can also be heavy on the computer, especially with many real-time shadows and bright lights. You can bake your lighting, which calculates the light once and saves it as a special texture on your objects. Baked lighting looks great and runs very fast, but it only works for objects that do not move. For moving characters, you can use a mix of real-time and baked lighting to get the best of both worlds. Let us talk about tags and layers, which help Unity organize and filter all your game objects. Tags are used to identify objects in code, like finding all items labeled pickup or enemy in a scene. Layers are used for physics and rendering, allowing you to tell the camera to ignore certain groups of objects. You can make a player layer and a ground layer and tell Unity that players should never collide with each other. If you have many similar objects, like bullets or coins, you should look into object pooling to save performance. Instead of destroying and creating objects constantly, you hide them and move them back to a starting position. This prevents the garbage collector from slowing down your game, while it cleans up all the old deleted objects. Object pooling is a pro-level technique that makes a massive difference in very fast-paced action games. Version control, like using Git, is essential if you are working on a game with a team of people. It allows you to save snapshots of your project, so you can go back if you break something. It also helps multiple people work on the same scene or script, without overwriting each other's hard work. Even if you are working alone, using version control is a smart way to keep your project safe from crashes. Train, test, we need to fix, repeat, until your game build is stable and runs perfectly on every device. Learning how to build and optimize is what separates a student from a professional Unity developer. Now we will look at some practice questions, focused on scene management, builds, and project organization for your certification. Question 1. Which class must you use in your C# code to load a new level during gameplay? You must use the Scene Manager class, which contains the functions for loading and unloading game scenes. This class is part of the Scene Management namespace, and it is the standard way to transition between levels. Question 2. What must you do first, before you can load a scene using its name or its build index? You must add the scene to the Scenes in Build list, which is found in the Build Settings window. If a scene is not in this list, Unity will not include it in the final game file. Question 3. What function keeps a game object alive, even when you load a completely new scene? You use the Don't Destroy on Load function to prevent the object from being deleted during scene changes. This is very useful for global objects, like your game's background music player or your player's inventory. Question 4. Which window in the Unity editor allows you to download and manage extra official features? You use the Package Manager window to install and update various toolsets and features for your project. This keeps your core project small, while allowing you to add only the specific tools that you need. Question 5. What is the main purpose of the Profiler window when you are testing your game? It is used to monitor performance and find out which parts of the game are causing lag. The Profiler shows you real-time data for CPU, GPU, and memory, helping you optimize your game's overall speed. Question 6. How does occlusion culling help make your game run faster on lower-end computer hardware? It stops Unity from drawing objects that are currently hidden behind other larger solid objects in the scene. By not rendering what the player cannot see, the computer saves a lot of processing power and runs smoother. Question 7. What happens when you bake your lighting instead of using only real-time lights in your level? Unity calculates the light once and saves it as a texture, making it much faster for the computer. Baked lighting looks very realistic, but it cannot change or move while the game is actually being played. Question 8. Which platform setting allows you to choose the game's icon and the name of your company? You find these settings in the Player Settings section, located within the main Build Settings window. This ensures your game has its own identity when a player installs it on their computer or phone. Question 9. Why is it better to load a scene by its build index rather than using its text name? Using an index is faster for the computer, and it prevents errors if you decide to rename the scene. The index is just a number, which stays consistent as long as the order in the build list stays the same. Question 10. What tool helps teams of developers work together without overwriting each other's recent code changes? Version control systems like Git allow many people to work on the same project files at the same time. It tracks every change, so you can easily merge your work or go back to an older version. Question 11. What is the difference between a tag and a layer in the Unity editor interface? Tags are for identifying specific objects in code, while layers are for physics and for camera rendering rules. Use a tag to find the player, but use a layer to tell a light to ignore the background, walls. Question 12. How can object pooling improve the performance of a game that fires many bullets every second? It reuses existing objects instead of creating new ones, which stops the garbage collector from causing sudden lag. Creating and destroying objects many times a second is very hard for the computer's memory to handle constantly. Question 13. Which namespace must be added to your script to allow for scene loading and unloading functions? You must add, using Unity Engine.Scene Management, to the top to access all the scene-related coding tools. Without this line, the computer will not understand what the Scene Manager class is trying to do. Question 14. What is a build in the context of creating a video game using the Unity engine? A build is the final playable file created for a specific platform like Windows, Android, or even WebGL. It packages all your scripts and assets into a single folder that players can run on their own devices. Question 15. What does the static checkbox do when you click it on a game object in the inspector? It tells Unity that the object will never move, which allows for many different performance optimizations and baking. If an object is static, Unity can pre-calculate shadows and combine it with other objects to save power. Question 16. What happens to the variables in a script when you load a new scene without saving them? All the data is reset to the default values, because the script is destroyed and then recreated again. To save data between scenes, you must use a persistent object or save the data to a file. Question 17. Which tool allows you to see a visual map of how much time each function takes to run? The profiler's CPU usage timeline shows you exactly which functions are taking the most time in every frame. This is the best way to find expensive code that might be making your game feel slow or choppy. Question 18. Why should you always test your game build instead of just testing it inside the Unity editor? Some things behave differently in a real build, like file paths, screen resolutions, and the overall game performance. Testing the final file ensures that your players will have the exact same experience that you intended for them. Section 6. In this final part, we will look at more advanced topics like animations and special effects. Animations make your characters walk, run, or jump, and they make the game feel much more natural. Unity uses a tool called the Animator Controller, which works like a map for all your movements. You can create transitions between states, like moving from an idle pose into a fast-running animation. To trigger these changes in your code, you use parameters like booleans, floats, or simple triggers. If you set a boolean named is walking to true, the animator will instantly switch to the walking clip. This allows your scripts to control exactly how the character looks and moves based on player input. Animations can also be used for simple things, like a treasure chest opening or a door swinging wide. Particle systems are used to create amazing special effects, like bright fire, thick smoke, or sparkling magic spells. A particle system shoots out many tiny images or shapes, which move and change over time. You can control how long they last, what color they are, and even how fast they fly. Using particles makes your game feel much more exciting, and adds a lot of visual polish to every action. Audio is another huge part of making a great game, because sound tells the player what is happening. To play a sound, you need an audio source component on an object and an audio clip file. You can make sounds 3D, so they get louder as the player moves closer to the object. This is perfect for a roaring campfire, or a loud monster hiding just around the dark corner. You also need an audio listener component in your scene, which is usually attached to the main camera object. The listener acts like the player's ears, picking up all the sounds coming from the various audio sources. Without a listener, you will not hear anything at all, even if your sounds are playing perfectly. Remember to keep only one listener in your scene, to avoid any strange audio errors or confusing bugs. Let us talk about prefabs again, because they are vital for organizing large and complex game worlds. You can nest prefabs inside other prefabs to build very detailed items like a house with furniture. If you change the master prefab, every single house in your entire game will update at the same time. This is a huge time saver, allowing you to build massive levels with just a few clicks. As you finish your project, you must think about how to manage your game's overall memory usage. Large textures and high-quality sounds can make your game take a long time to load for players. You can change the compression settings to make these files smaller without losing too much of the quality. Keeping your game size small is very helpful, especially for people who have slow internet connections or small phones. The Asset Store is a great place to find 3D models, sounds, and scripts that others have already made. You can download free or paid assets to speed up your development and make your game look better. However, you should always make sure you understand how the assets work before adding them to your project. Learning to integrate different tools is a key skill for every modern game developer working today. Finally, we need to talk about the importance of testing your game as much as you possibly can. Ask your friends to play your game, and watch closely to see where they get stuck or confused. You might find that a jump is too hard, or a menu button is too small. Use this feedback to improve your game, and keep fixing things until everything feels exactly right. Train, test, we need to fix, repeat, until your game is a masterpiece. Becoming a Unity certified user is a big step, and it shows everyone that you know the basics well. Keep practicing your coding every day, and do not be afraid to try out new and difficult ideas. The more you build, the better you will become at solving problems and creating fun experiences. Good luck on your exam, and I know you will do an amazing job on it. Now let us look at the final set of practice questions to wrap up your learning session today. These questions cover everything from animations to audio, and they are very common in the programmer exam. Think carefully about each answer, and remember all the small details we have discussed in this video series. Question 1. What tool do you use in Unity to manage the transitions between different character animation states? You use the animator controller to define the rules for when one animation should switch to another. It works like a flow chart, using parameters to trigger changes like moving from idle to running. Question 2. Which component is responsible for actually hearing the sounds that are playing inside your game world? The audio listener component acts as the ears, and it is usually placed on the main camera. You should only ever have one listener in a scene to ensure the audio is calculated correctly. Question 3. What system should you use to create visual effects like fire, explosions, or falling snowflakes? You should use the particle system, which can emit and animate thousands of small objects at once. It is a very versatile tool, used for almost every moving visual effect in a modern Unity game. Question 4. How do you trigger an animation change in code if the transition depends on a speed float? You use the function animator.setFloat to pass the player's current speed into the animator. The animator then checks this value and switches to the run animation when the speed is high enough. Question 5. What happens if you have two audio listener components active in the same game scene at once? Unity will show a warning message, and the sound might behave strangely or stop working entirely. The computer gets confused about which ears to use, so you must always stick to just one. Question 6. Why would you use a prefab variant instead of making a completely new prefab from scratch? A variant stays linked to the original prefab, but it allows you to change specific parts of it. This is great for making a red car and a blue car that both share the same basic logic. Question 7. Which component is required on a game object if you want it to actually play a sound file? You must add an audio source component, which holds the audio clip and controls how it plays. The audio source has settings for volume, pitch, and whether the sound should loop forever or not. Question 8. What is the benefit of changing a texture's compression setting in the Unity import settings window? It reduces the file size of the texture, which makes your game load much faster and use less memory. This is vital for mobile games, where you need to keep the total app size as small as possible. Question 9. How can you make a sound get quieter as the player character walks away from the sound source? You must change the spatial blend setting to 3D and adjust the min and max distance values. In 3D mode, Unity automatically handles the volume based on how far the listener is from the source. Question 10. What does the loop checkbox do when it is enabled on an audio source component in Unity? It tells the sound to start playing again from the beginning, as soon as it reaches the end. This is perfect for background music, or ambient sounds like wind and rain that should never stop. Question 11. Which window allows you to see the individual animation clips that are assigned to an object? You use the animation window to view and even edit the keyframes for your different animation clips. This is where you can manually change the position or rotation of an object over a specific time. Question 12. Can you animate properties other than position and rotation using the Unity animation system? Yes, you can animate almost any property, including colors, light intensity, and even Boolean values in code. This makes the animation system very powerful for creating complex and interactive visual effects in your levels. Question 13. What is a trigger parameter used for inside an animator controller state machine? A trigger is like a Boolean that resets automatically once it has been used to change a state. It is perfect for one-time actions, like a jump animation or a character taking a quick hit. Question 14. How do you stop a particle system from playing as soon as the game starts up in play mode? You uncheck the Play on Awake box in the main settings of the particle system component. You can then use a script to start the particles only when something specific happens in the game. Question 15. What is the asset store, and how can it help you as a lone game developer working alone? It is an online shop where you can get pre-made assets, which saves you time on art and coding. It allows you to focus on your game's unique features, while using high-quality ready-made building blocks. Question 16. Why is it important to watch playtesters while they are trying out your game for the first time? It helps you find bugs and confusing parts that you might have missed because you know the game. Seeing a fresh player struggle with a level gives you the best information on what to fix next. Question 17. What is the console window used for during the final testing phase of your Unity project? It displays errors, warnings, and custom log messages that help you track down any hidden coding bugs. Even if the game looks fine, the console might be showing red errors that could cause a crash. Question 18. What is the final goal of the train, test, we need to fix, repeat cycle in game development? The goal is to create a stable, fun, and high-quality game that is ready for players to enjoy. Constant improvement is the only way to reach a professional standard and pass your certification with flying colors. You can get my complete practice test link in the description or at the first comment of this video. These questions come with full explanations, which will help you get your certification on the first try. Please leave suggestions in comment section to improve my videos. And don't forget to subscribe.